So we have questions here. Now question number 4, we have 1 minus 9y squared. We're asked to factorize. Remember, the instruction is still the same, factorize. Now, when you're given a question, you will not necessarily be told the type of factorization technique to use. So you should be, conversant enough with these concepts and techniques that as soon as you look at the question, you know the one to use. Now, you see that we have 1, and then we have minus. So whenever I see minus, what should come to my head is difference of square. Probably this might be difference of square, and then it's also proving to be so because you see that 9 is the same as 3 squared, and then y is already squared. 1 is the same thing as 1 squared. So let's write all this thing. This is the same thing as 1 squared minus 3 squared y squared. So it's now like a difference of square. So let's join the other part together. So we have 3y all squared. Now we have 1 squared there, we have 3y squared there. Remember, difference of square, if you have x squared minus y squared, we say that factorizing this will be equal to x plus y, the sum, x minus y. So we're going to do the same. This is the same thing as 1 plus 3y times, I'm used to writing x, 1 plus 3y, and then 1 minus 3y. We factorize because this is a difference of square. Now the next question, you see that this is also looking like a difference of square because we have a square here. 25 is something as 5 squared and 16 is 4 squared. So let's just write everything. So we have 4 squared minus 5 squared times a plus b squared. Now remember, I'm multiplying, you can distribute. So let's just rewrite that as a whole. That is 5 squared minus, let's just put all of them in the brackets. We have 5 times a plus b, all squared. So that's what we have. So we might want to simplify what's inside this bracket, further. So 5 times a is 5a, and then 5 times b is positive 5b. Let me use the same brackets, all squared. Now we have just a single term all squared, and then 5a plus 5b is a single term. We regard it as one term all squared. So we can apply difference of squares now. So we're going to say that the answer will be 4 plus 5a plus 5b, open another bracket, 4 minus, let me put this in the bracket and I'll show you the reason why. That's what we have. Now let's simplify this bracket. The reason why I'm putting it in a bracket, you see, anytime you have minus, notice that it's going to affect this positive sign when you expand. So it's always important to, when you're having the negative sign, put the other terms in a bracket, especially if you have 2 terms like we have there. So let's simplify further. So finally our answer is going to be 4 plus 5a plus 5b times 4 minus minus times this 5a will be minus 5a, and then minus times positive 5b will also be minus 5b. So we have factorized that one. Now let's check the next one. Now question number 6, we have x minus y squared. Now we're going to take it as one term. We have m minus n squared. We're going to take it as one term. So factorizing using difference of square, this is going to be x minus y plus m minus n. Anytime you're adding, don't need of putting anything in the bracket because multiplication will not affect any sign. And then x minus y minus, now remember, I'm just going to do this straight. Remember what we did in this example. Negative is going to affect the sign, so we're going to now have m plus n, right? Because this minus times this minus will give you plus. So take note of that. So that will be the answer. We cannot simplify further because x, y, m, and n are not like terms. So that's just our answer. So let's go forward. Now we have another question, the question number 7. Now remember, like I said, that you're not going to be clearly told the factorization technique to use. You just have to look at the question and try to figure out what to do. So you see, we have a square there, rather we have difference, so we're looking for difference. That's a minus sign there. But then what should come to our hand now will be difference of squares. But clearly you can see that we don't have any square, rather we have cube, right? This is raised to power 3 raised to power 3. So the next thing that should come to your heart is difference of cubes. Now, remember from the previous video, said that if you have difference of cube, that is, let's say x cube minus y cube, generally now, so that factorizing this is the same as x minus y, times s squared plus xy plus y squared. So remember this factorization technique. So that's what I'm going to apply there. But then 8 is not yet in the cube form, and 27 is not yet in the cube form. So we're going to write that which number raised to power 3 is 8? 2 times 2 4, 4 times 2 8. So 8 is the same as 2 raised to power 3 a raised to power 3 minus 3 squared, 3 cube rather is 27. So this is 3 cube b cube. Alright, so let's just write it as a whole. 2a cube minus 3b cube. So let's factorize using this technique. So we have this will be equal to the first term, which is 2a, minus the last term, this other term, which is 3b. It's also safe to say is the last term, right? Then multiply by the first term squared. Let's just do it straight, because 2a squared, 2 squared will be 4, a squared will be a squared, plus the first term times the last term, right? Because you see that this is xy, meaning the first term times the last term. So the first term is 2a, 2a times 3b, 2 times 3 is 6, a times b is ab, then plus the last term squared, 3 squared is 9, b squared is just b squared. So that is the answer. We factorized that expression. Now the next question, which is question number 8, you see we have b cubed plus 64. Now b is already in the cube form, 64 is not in the cube form, and then you notice that we have plus now, not minus. So this will be sum of cubes. Remember, sum of cubes is the same thing with this, just that the signs are just a little bit reversed. So this will be x plus y, s squared minus xy plus y squared. So in this case it's going to be minus. So let's do the same. This is b cubed plus, which number raised to power 3 is 64? That will be 4 raised to power 3, because 4 times 4 is 16, 16 times 4 is 64. So this will be equal to the first term b plus the last term 4 multiplied by the square of the first term, which is b squared, minus the first and the last term, they are products, that's b times 4, which is 4b, then plus the last term squared. 4 squared is 16. So that's the answer. So you can always rewind this video just in case many of the things are not very clear to you. Just rewind the video, watch again until you master the concept. So let's go further. Now look at the question there. It says, given that the sum and product of alpha and beta, these are Greek alphabets, alpha and beta, so the sum and the product are 2 and negative 3 respectively. Evaluate alpha squared plus beta squared. Now remember that we don't have any factorization technique for sum of squares. However, I thought you that when you're given the sum and the product, you can always use this technique. So simplifying, we have this will be equal to sorry for that. So this will be equal to, we open a bracket. Now you see in this bracket we have alpha plus beta, that is sum, and then here we have products, because that's alpha times beta. So we're going to replace alpha plus beta with the sum. Remember from the question, the sum is given as 2. So the sum is 2. So I'm going to replace it as 2 squared minus 2 times alpha plus beta. Alpha times beta, that will be the product. And from the question, you see that the product is negative 3. So 2 into negative 3. And that's it. So we just simplify. 2 squared is 2 times 2, which is 4, minus 2 times negative 3, that would be negative 6. So we save to put it in the brackets. So we have minus minus, they're giving us plus. So that's 4 plus 6 and 10. So our final answer is 10. And that's it. So these are some of the examples that I promised us we're going to solve. So I hope this video was helpful. So if it was indeed helpful, I would like for you to subscribe to this channel if you haven't, and share this video with your friends. Comment if you have any question. You can always drop it in the comment section, and I'm going to respond to it shortly and as soon as possible. Thank you. God bless you.